let's start solving problems on exponential differentiation. Alright, there are few simple problems. Let's solve them. Look at the problem. There are 5 of them. The first one will start. See, y is equal to e power sine inverse x, right? It's a composite function, isn't it? See, whenever you have a composite function, what do we do? Let's say u is equal to sine inverse x, right? Now y dash or y, let's start with y first. Y is equal to e power u, isn't it? So y dash becomes e to the power of u into du by dx. Now when you have e to the power of u into du divided by dx, now e power u, you know, du by dx you need to do it, isn't it? So you will get it as y dash is equal to e power sine inverse of x into d by dx of sine inverse x, right? E power sine inverse x into 1 by root 1 minus x square. This becomes y dash. So the answer for this one is going to be this. Clear? This is going to be the answer. Now let's do the next one now. See the second one. Y is equal to e to the power of x cube. Again, it's a composite function. A very simple type of composite function, right? Say y is equal to e to the power of, again, e power u, right? Where u is nothing but x cube, correct? So y dash is equal to e power u into u dash, or in this case, y dash is equal to e to the power of x cube into d by dx of x cube, correct? So y dash is equal to e power x cube into 3x square. So this is going to give me the answer for the second question. All right. Likewise, we'll do the third one. See the third one. Y is equal to sine of tan inverse e power minus x. Right. So the inside part will start. Okay. Say you have u is equal to tan inverse of e power minus x. First part. Next, say v is equal to e power minus x. Basically, what we'll have is y is equal to sine u, correct? Y is equal to sine u. Let's do this one. So you get y dash is equal to cos u into du by dx. Isn't it? This is the first part. Now let's do the next one. Because see, we need du by dx, right? So what is u? U is tan inverse v. E power minus 6 is v, right? So du by dx 1 by 1 plus v square into dv by dx, correct? So you get u dash is equal to 1 by 1 plus v square into e power minus x derivative, correct? D by dx of e power minus x. In other words, u dash will be 1 by 1 plus v square into e power minus x into minus 1. We get the minus 1. The reason why we get minus 1 is you're differentiating minus x, right? Minus x derivative is what? Minus 1. That's why you get this. Fine. Let's apply all of them together. When you apply all of them together here, what you have, y dash is equal to cos of u, right? See, what you have now is y is equal, or y dash is equal to cos of tan inverse e power minus x into 1 divided by 1 plus e power minus x whole square into e power minus x into minus 1. So I'll write the last minus sign here. Understood? So this is going to give us the entire answer. This is the whole answer. This is the answer for the third one. Fair enough? Let's do the fourth one now. See the fourth one? Y is equal to e power x plus e power x square plus e power x cube e power x power 4 plus e power x power 5. So y dash will be e power x is e power x itself. There is no change. Next one is going to be e power x square into 2x, isn't it? Because x square derivative is 2x plus e power x cube into 3x square e to the power of x power 4 into 4x cube e power x power 5 into 5x power 4. Correct? See here you can take common in the last 4 terms, but to be honest, I would say that you can just keep it as it is. Just rearrange and keep it as it is. All right. So what you can write is y dash e power x 2x e power x square 3x square e power x cube 4x cube e power x power 4 5x power 4 e power x power 5. So this becomes the final answer. Again, I'm telling you, you can simplify it by taking common in the last 4 terms, but even if you keep it as it is, it's okay, well and good. This is the correct answer. Fine. Let's do the last one, the fifth one right now. The fifth one, see, y is equal to root of e power root x, isn't it? Again, it's a composite function. So take e power root x as u, first one, root x as v. All right. So what do you get now? Y is equal to root of u, correct? If you differentiate this, y dash is equal to 1 by 2 root u into u dash. So first you need to calculate what is u dash, right? So to calculate that, u is nothing but e to the power of v. Root x is v, right? So u dash will be e power v into v dash, correct? Or u dash is e to the power of root x into d by dx of root x, isn't it? So u dash will be e power root x into 1 by 2 root x. Derivative of root x is 1 by 2 root x. So substitute this u dash here in this place. All right. So if you're going to substitute that, you will have y dash is equal to 1 by 2 into root of u, which is e power root x. E power root x. 1 by 2 root u into u dash is nothing but e power root x into 1 by 2 root x. Clear? Now you can further simplify this. To be honest with you, we can do a lot of simplification here. All right, so what simplification we can do is we can actually cancel this one and this one, put the root above. We can do a lot of simplification. The 2 and 2 you can multiply and write it as 4. All right, so if you do the simplification, then we can write y dash will be root of e power root x divided by 4 root x. So this is going to be the answer. The final answer, what you can write is going to be this. Fair enough? The answer for the fifth one is this particular one. Now, the problems, whatever you just saw, these 5 problems, these are like basic problems of exponential differentiation. All right. In the next video, we'll discuss about logarithmic differentiation. That means first you need to understand what are log functions, how do we define log functions, what is the graph, what are the rules and regulations of logarithms. After learning everything, then we'll go into the logarithmic differentiation. Alright, so in the next video, we'll start by understanding what are log functions and how do we express them, how do we differentiate them. Alright, that's what we are going to do in the next video.